All right, so this next section, 13 through 17, is asking us to evaluate by factoring or dividing. So if I take a look at 13, I don't necessarily want to spend a whole lot of time trying to factor. We could, but I'm thinking probably not going to factor for us. I'm going to try some division. If I'm dividing by x plus 1, I'm going to put the negative 1 in the box. So I have a 2x squared, a 1x, and a 2 going across the top. So I'm going to drop the 2 all the way down, and I'm going to multiply, and I'm going to add, and I'm going to multiply, and I'm going to add. And that remainder of 3 is what tells me that that wouldn't have factored anyways. So that's okay. I saw it anyways. We did not take the antiderivative. All we've done is to rewrite this into a 2x minus 1 with a 3 over x plus 1, right? There's my third term. But now it's 3 terms to take the antiderivative of. So the antiderivative of 2x is x squared. The antiderivative of negative 1 is negative x. The 3 stays in front, and that parent function is 1 over x. The antiderivative is natural log of the absolute value of x plus 1 plus c. So let's take a look at the next one. So the numerator changed a little bit. The denominator did not. Did a little bit, sorry. And again, we could sit up here and we could try to factor, and that's fine if it does. Or we could say, oh, we're dividing by x minus 1. Let's just go ahead and see what happens. I'm going to drop the 2, multiply, add. And I saw that this was going to happen, that we get a remainder of 0. And when we get a remainder of 0, that means this numerator did factor. And by the way, when we got rid of it, we were left with a 2x plus 5. So no remainder, it just meant that that numerator could have factored. But great, because now I don't have a quotient, I don't have a product. We're just going to take the antiderivative. The antiderivative of 2x is x squared. The antiderivative of 5 is 5x. And we're going to evaluate that from 0 to 3. It's one of the easiest integrals we've seen. In fact, we saw something like this in Unit 5, right? If it factored, that's something we've been doing forever. So let's see, I'm going to get a 9 plus 15 minus, when I plug in the 0, I get a 0. So 24. Good. Now, take a look at 15 real quick. Whoops. If you look at 15, it's just this same thing flipped over, right? The thing is that on 15, long division wouldn't have gotten there for us, right? So the only time we're going to use long division is when the numerator is bigger than the denominator. Well, here that's not the case. And if we hadn't really seen what just happened, that's when I think we would try to factor, right? I know we already know the answer. I'm just going to pretend we're starting this one from scratch. I have an x minus 1 on top. And on the bottom, we're going to just try to factor as best we can. How about a 2x plus 5 and an x minus 1? Perfect. That's how we're going to clean this up. Now, the parent function is 1 over x, so the antiderivative is the natural log of the absolute value of 2x plus 5. But the chain rule says divide by 2. So you see how differently that one ended? We had a 1 over x. We had a kind of a chain rule kind of thing. Whereas back here on number 14, we didn't have a 1 over 2x plus 5. We said 2x plus 5. So we could treat those as 2 separate terms. Okay. All right, let's take a look at 16. Well, we've got some bounds, so we'll make sure we come back to that. I'm going to use long division. Well, I'm going to use synthetic division. So I have a 1x cubed, a negative 1x squared, a negative 11x, and a negative 5. Let's see, 12 minus 11 is 1, 4, and we have a remainder of negative 1. All right, now we have bounds. Again, we'll come back to that. X cubed divided by x will give me an x squared. So I have a 1x squared, a plus 3x, and a plus 1, and then minus a 1 over x minus 4. That is not the antiderivative That's just us cleaning up the integral. Now we can take the antiderivative of each piece separately. And just like we saw on number 15 and on number 13, right, that antiderivative of that 1 over x is the natural log of the absolute value of, in this case, x minus 4. Okay, here we go. Let's start by plugging in the 1. And when I plug in the 1, I'm just going to do it very literally. I get a 1/3 plus 3/2 plus 1 minus the natural log of, well, let's see, -3, but the absolute value would make it a positive, minus, and then I'm going to go plug in the 0, and I get 0 plus 0 plus 0 minus the natural log of, well, let's see, we'd have a -4, but we want the absolute value. And you can leave it like that, and great, right? But what we need to pay attention to is that we're going to distribute that negative. So I have a 1/3 plus 3/2 plus 1 minus the natural log of 3 plus the natural log of 4. And that answer's fine. You can do whatever you want in there. You can leave it as 1/3 plus, let's see, that'd be 5/2. And then if you switch these so that it's subtraction, that's when you can write that as a log with division. Clearly there's a lot of, clearly there's a lot of ways to write this answer. If it were multiple choice, then we'd know when to stop. But if it's not, then you get to stop whenever you want.